Everyone, this is Rajiv here. In the first video, we have already studied how to calculate the value of mean using the instructions which are available with 80387 coprocessor. And whatever system calls are needed for that, we have already studied in the first assignment or in the first video. In this video, we will see how to calculate the variance and standard deviation values. As we already know the formula for calculating the variance, and one of the definition is mentioned on this particular slide that we will see, the value of deviation variance is calculated by subtracting the mean from each of the data point, and then we are taking the square difference of the same. Whatever values whatever values are generated from the differences, we are adding all those values, and finally we are dividing that particular value by the value of n. The value of n is nothing but the count which is available in the array. In our example, we have taken the 5 values in the array. That's why the count value will become 5 in this case. If on this slide the logic behind variance is demonstrated here, as we know the 5 values we have already taken in the array, that array is pointing to one of the index, that is nothing but the source index. That means array or RSI will point to the first value which is available in the array. Then as we know the array is having 5 value, that's why we have considered the count value as 5. Then as we already know, to remove the garbage or to avoid the garbage problem, we are clearing that particular garbage value by putting the constant value of 0 in the stack. Then we have loaded the value of RSI. As RSI is pointing to array, the first value of RSI or array is loaded on top of the stack. Then we are subtracting that particular value from the mean value which is already calculated in the first video. Then we are subtracting the mean value from each and every data point. Then we are multiplying that value by itself because we have to take the square difference of the same. Then we are adding that value with rest of the data points. That means this particular loop is executed 5 times because we have taken 5 values. Every time the value is subtracted from the mean and then added. That's why this particular up1 loop is executed 5 times. Then as the formula states, we have to calculate the square difference and then we have to divide that particular value by count. The value of square difference is already calculated in the up1 logic. Then we are dividing that particular value with the count value, and whatever value is generated on top of the stack, that value we are storing in the memory in the form of variance 1. Now we have calculated the value of variance, but still the display of that particular value on console is still remaining. That's why we are calling to disproc. So in disproc, the value of hdec we have already declared in section.data, and we are multiplying the value of variance with this data. Then we are executing the instruction fbstp t-word resbuf. The reason behind executing fbstp is this instruction pop the extended precision value from top of the stack. Extended precision is nothing but the 80-bit value which is storing in top of the stack, and convert that particular value into 80-bit BCD because console can understand the 80-bit BCD value. That's why this instruction is written here. As we already know, we have taken the 10 bits of data, 10 bytes of data, or declared 10 bytes of data in resbuf. That's why resbuf is pointing to RSI plus 9 values are there because total 10 values are we have considered. Then we have taken the count value as a 9 because total, in order to display 10 value, we are taking the counter value as a 9 because microprocessor will start from 0. That's why from 0 to 9 are nothing but the 10 values. Then we are pushing the value of count on the stack. Then we are pushing the value of RSI. Whatever RSI value is there, that means from the LSB bit, we are taking that value and moving into BL. Then we are calling to display routine. Here, this display routine we have already studied many times. Display routine, the purpose of display routine is to display or to convert hex value into ASCII so that computer can understand the values which are displayed on the console. This particular routine is displaying the two digits of value, that means 8 bits are displayed by using this display routine, and the logic we have studied many times. Here whatever value is coming in BL, we are rotating that value by 4, then that value is stored into DL, then we are performing masking operation to make one of the values 0, then we are adding 30 in that, then we are comparing with 39. If the value of DL is less than or below the 39, then we are moving that value into RDI directly, and then we are incrementing the value of RDI. In this fashion, this particular display routine is executed 2 times because the value of counter is 2. Then whatever value is generated, that value will go into RDI, and as RDI is pointing to temp, here we are printing the value of here we are printing the value of temp. This particular routine is executed 9 times. That means this routine is responsible from next one to here up to loop next one. That means 9 times this particular routine is responsible for executing the value after dot. So the value before dot is also remaining. That's why again we are pushing the value of RSI. We are executing write macro to display the value of point. Then we are for displaying the value before dotted decimal. Again we are taking the value of RSI into BL and we are calling to display routine. By the same logic, we are printing the value before dot also. That means before dot value and after dot value both are printed by executing the disproc routine and display routine. In this fashion, the value of variance is printed. Then we will switch to, or we will move towards deviation part. So in the formula for deviation is very simple, and the logic of deviation is also very simple. The formula for the deviation is nothing but the square root of variance. As we have already calculated the value of variance in the first part, then we just need to take the square root of the same, and one of the instruction is already available with 80387 coprocessor, and that instruction is nothing but fsqrt. So we are just executing, we are just placing the value of variance on top of the stack, and we are taking the square root of the same. Whatever value is generated there, we are supplying that value to disproc routine. The disproc routine is again executed the same routine, just same as the variance. Again, whatever values are generated, that values are displayed with the help of display routine, and in that fashion the deviation part is also executed. Hope so all of you must got the logic of variance and standard deviation and procedure for displaying the variance and standard deviation. So in this fashion we have studied all the calculation of mean, variance and standard deviation, and our 12th assignment is completed. Hope so all of you got the concept. Thank you so much.